Hello everyone, this is a video lecture for pre-calculus. We're going to do 4.2 logarithmic functions, or I guess you could just say like logs or logarithms or something like that. Anyways, so what is a logarithm? Let's start with that. Well, actually first let's start with an exponential. So an exponentials are y equals b to the x. So b is your base, and well, we just learned about that in the last section. A logarithm looks kind of like y equals log base b. Let me make sure I make that look good for the first time here. Log base b of x. So there's a little base b. It's a little subscript thing there. Some examples would be, say, log base 2 of x, or that's a really weird y. Log base 5 of x, or log base e of x. But this one is special. It's actually written as ln. Let me just emphasize that is an ln, not an in. Font changes are kind of weird nowadays. So ln log natural. There you go. So natural base, natural log, all that kind of stuff. Cool. So that's a logarithm. Now, they're kind of similar. They're not the same, but they're similar. They're actually inverses of one another. Inverses. And so how do we work this inverse stuff here? Well, it's like you switch x and y, move to the other side, and solve, and da-da-da. Well, I'm going to do it a lot easier. I'm going to do it quicker. And so let's start with something that we do know for sure. 2 cubed is equal to 8. Is that a true statement? Yes. So I want to rewrite this in log form. I'm going to rewrite it like this is the same true statement over here, same thing. Here we go. So this is log base 2 of 8 is equal to 3. So what's happening here is that you're saying 2 to what power is equal to 8. That's how it's stated. You're saying 2 to some power is equal to 8. And what is that number? What's that power? It's a 3 right there. That's a 3, which would go back to this guy, right? Well, cool. When I do this, I think of it kind of like friends. And so let me show you what I mean by that. 2 and 3 were good friends, but no longer. 2 and 3, they're no longer friends. They're really far away from one another. So they used to be friends. Now they're really far away. 8 was all by himself. He was kind of alone. He didn't know what to do. And now 2 and 8 are good friends. They're right next to each other. And I'd like to make small stories with this along the way. So if you don't like those, skip ahead 10 seconds each time. So let's just do some problems, and we'll learn as we go. So 4, 2, 3, I got 5 is equal to log base 4 of m. And they want you to rewrite. They say rewrite into exponential form. Well, my base is a 4, okay? So let's always start with our base, and then I have up top and on the side. And I want to rewrite it thinking like friends, okay? I'm going to write that up so you kind of hear me, I guess, and see it. Friends. So 4 and m were good friends, right? So you would think he still sticks around there. Nope, no longer. You're not my friend anymore. You're my enemy. So frenemies. I don't know how you spell it. Anyways, frenemies. But 5 was all by himself, and hey, 4 and 5, they're like good friends. They're right next to each other on the number line. Number line lane, right? They're neighbors. Okay, anyways. So that's it. Actually, you're done. There's nothing else to do here. It's 4 to the 5th is equal to m. I know that you can say, well, I know what 4 to the 5th is, and you go to the calculator and stuff. I don't care about that. They don't care about that. That's it. You're done. No more. Stop. Don't do any more. That's it. That's it. Don't solve for m. You're done. Next question. Seriously, you're done. Don't do it. So I've got square root of 16 is equal to 4, and they say rewrite, blah, blah, blah. This is actually an exponential as it is. It's 16 to the 1/2 is equal to 4. And so I want to rewrite now with logarithms. So you always start with your base. Base is 16 right there. So base is 16. And then I got of something equals something. Now, 16 and 1/2, they were good friends. No longer. You're half the person I knew you were. That was really lame. I know. I'm going to keep doing it, though. So I have, and then 4 was all by himself. And now 4 is a friend. 4 is a friend with 16. Wow, you're You're a multiple of me. I don't know. Anyways, that's it. That's it. You're done. There's nothing else to do there. Don't do anything else. Don't do anything else. Don't do anything else. Don't do it. Okay, we're moving on. So we have, it says graph, if you can read that, is y equals 3 to the x, and graph y equals log base 3 of x. They want to kind of show what this inverses thing is. So the 3 to the x is going to look like this. Awesome. I'll just remind you, hey, that's 3 to the x. And then I'm going to use a different color, and I'm going to do this guy here. This is log base 3 of x. And when I said inverses, you can see that they're mirror images about the y equals x line, that 45-degree line. And that's why they're inverses of one another. Okay. Cool. Next page. So number 4 to 47 all the way through 52 is another graphing matching. And so let's go through all that. Y is equal to, and I've got log base 4 of x, and so on and so forth. So we're matching up the graph with that function. I'm going to say this is the most basic one out of them all, and I want to see what that graph's going to look like. Well, you do this. There you go. There's a logarithmic graph. And these logs, they keep going up forever and ever. They don't like stop. They just keep going, but they just go slower and slower. It won't ever stop, though. It does always keep growing. One thing is that it's crossing through here at 1, and in this particular case, we got 4, comma 1 is one of my other points. Note that the 4 is my base, therefore I'm going to have a 4 when it hits at 1. Similar with the exponential, by the way. This is all tied in with inverses and stuff. It would be 1, 4. So to do inverses, you switch x and y. Okay, good. So anyways, this is your graph. Match it up. You're done. Now, the rest of them are going to be modified from this one. So we got log base 4 of x minus 1. Now, notice that this is going to go to the right because it's inside opposites and all that kind of stuff. So there's a vertical asymptote here at 1, and then it grows. This guy is now going to be at a 2. Cool. We have the next one, which would be log base 4 of negative x. So that's going to flip it horizontally. My original looks something kind of like this, and now the new one looks like that. Okay, the next one, I've got log base 4 of x and then minus 1. Notice that it's like not on the inside at all there. This one is going to go down by 1, and so down. And so when it does this still, it looks just like that, but it's actually going to be touching here now at 4, not at 1, because it just dropped down 1. Okay, we got negative log base 4 of x. Good enough. Okay, and so what's going on here? Negative here is going to flip it upside down. So my original looks like this. Now the new one looks like that. Cool. Last one, and this is the most complicated one, 1 minus log base 4 of x. There's actually two things going on. This is a positive 1, so this is actually going up, but it's also going to flip it upside down. I would say, because it's matching, just do the one that's weird. Do the one that you haven't used yet, you know. But it's going to be upside down for sure, and it's going to be shifted up, which actually makes it touch here at 1, comma 4. Blah, blah, blah. We're done. So next question. Okay. So 4275, it says, find the domain of this logarithmic function, f of x is equal to, and then I got log base 2 of x minus 2. And to find the domain of all this stuff, we're going to take the inside and set it equal to 0. Inside equals 0. And this is super easy to do. Solve for x, blah, 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 x equals 2. Now, this is kind of like a start to your domain, it's also a vertical asymptote, so you can't really actually touch it. But this is a start point, basically. So your domain is actually pretty simple. It's 2 to infinity, but using a parentheses because that 2 is a vertical asymptote, okay? Basically, with logs, just always use the parentheses. There you go. Okay. Let's do another one. And this one I did because it's a little confusing. And I don't like it personally, but I don't make these questions up. Okay. There you go. So it's another log. Notice that this log doesn't have a base. That's actually the common base, and it really doesn't matter for what we're doing here. They still say, hey, find the domain, just like the last one. So I'm going to take the inside and set it equal to 0. Guess what? Solve for x. It's actually a positive 3. Now, we're not used to seeing it in this manner, but what if you add x to both sides, right? So that way it would be 3 is equal to x equals 3. Same thing, right? Well, my first inclination is that it's going to be 3 to infinity, but that's not the case. It's actually negative infinity, if I could draw that, that is, negative infinity to the 3. And that's your actual answer. Now, why is it backwards? The reason why is because there's a negative sign right here in front of the x. What they're really wanting you to do is test out some values. So we can test, if there's 3 right here is kind of the important number, you can test a 2 and you can test a 4. And the 2 works, but the 4 does not. When you test it in a calculator, you get like log a -1. That just doesn't work. So none of this stuff works over here. What does work is all this. And so you're going to say negative infinity all the way up to 3, and you're done. So there you go with that one. Next question. So 4 to 85. I have 10 to the power of log of 48. Now, again, I just stated this, but see how it doesn't have a base? If it does not have a base, it's actually a base of 10. That's a common base. It's called common base. I'm just going to write common base. So 10. It's a log base 10. And I know that all this is review, and I'm kind of going a little fast compared to, I guess, new lecture material. But what happens here is that this is 10, and that's a 10, and they cancel, and your answer is a 48. Very simple. So they cancel. The same bases cancel. It's one of those properties, I guess you could say. I'm going to do the next problem, and then I'll go back to the one I just skipped, I guess. So here's another one. It says ln of e to the 5x, and it says simplify. What is this guy equal to? Well, that ln is log base e of e to the 5x. And so the e's are going to cancel, and it leaves a 5x. So e and ln cancel, basically. Just you can do that. Original is totally fine. And so we have to see that there's these strange bases sometimes. Sometimes they just pop it out there. Here's another easy example. Log base 2 of 2 cubed. The 2's are going to cancel and make a 3, right? It's super easy to do all this stuff. Don't overcomplicate it. Okay, so here's one more. So 285. It says find ln of 1. Again, that's log of 1. It's all the same in this particular case. I would say go to the calculator, and it's just a 0. You can also see graphs of this right here. You're like, hey, what's going on at x equals 1? And it's like, oh, that's a 0, right? Y equals 0. I don't know. Either way, it's fine there. So ln and log are the same in this particular case. I'm not going to say they're always the same. But in this case, ln of 1, log of 1, they're all equal to 0. So no big deal there. Let's keep cruising. 4 to 101. So I have a log base 2 of x minus 3 is equal to 3. And it says solve for x. I love solve for x. It's like a happy place in my mind. Yay. So what I'm going to do is I'm going to rewrite it using friends. And so you start with your base, and then you got up top and on the side. Okay. Well, 2 and x minus 3 were good friends, but you have exceeded my limits. Excuse yourself for my presence. I know, whatever. But 3 was all by himself, and 2 and 3 are good friends now. They're like neighbors right next to each other on Numberline Lane. So, I'm so lame, I know. But hey, you are going to remember this. That's the point, right? Solve for x, add 3 to both sides. You know the drill here. Answer is 11. So, cool. That was fun. Yeah, and wrong. What? Why is it wrong? What do you mean? Well, this is part B. My math lab. Part A says, we'll rewrite it as an exponential equation. So this is your part A, which we basically already had. But it's just so annoying. Like, just let me solve for x. 4, 2, 1, 1, 1. So they have f of x is equal to log of x plus 4 over x minus 2. And they say, find a domain. My D's just never come out very good. Domain. Okay. So to find the domain, you're setting the inside equal to 0, right? This one is a little different than the others. Notice that if I set it equal to 0, that's technically only the top. And so therefore, I would say x equals negative 4. But I feel like this 2 is also important, right? So this is a vertical asymptote. And this is a 0. But then again, the 0 on the inside makes it a vertical asymptote. And it's all just kind of what is going on here, right? So let me tell you what I do here. I'm going to go down Numberline Lane, and we're going to just test some values. So I have negative 4, and I guess that's 0 right there. And then we have a 2. And I want to test all the numbers basically around these guys, not the 0. He was just there for reference. So negative 5. I'm going to test the negative 5 way over here. I'm going to test 0 because that's super easy on the inside. And then I'm going to test a 3. And by test, I mean I'm going to plug it right back into the original, use a calculator, etc., etc. I don't even know if I did this on my notes here. Let me look. I did, yeah, I did. So I plugged this in, and what I didn't do is actually give you the answer. So on my notes, I don't have a number there for you, but I mean, you can go to the calculator. It's going to give you a number, and it's going to give you a positive number, and that's kind of the point here. I think if you just do the inside, you'll see it's positive, and log of a positive works. So it's kind of like log of a positive. Now, if you did the 0, then you have 0 plus 4, and you got a 0 minus 2, and that's going to be a negative number. So you can't have log of a negative, and so log of a negative is no good. So that didn't work. This works, and just guess what? This one works as well. So you plug it in, same thing, blah, blah, blah. You get a positive, and it works. So those are my two answers. I'm going to say negative infinity all the way to negative 5, and then union 3 to infinity. And there is your answer. You're done. Cool, cool. Wait. Wrong. I can't believe I did that. That's okay. I don't mind. I mess up. Negative 4, 2. So what was I thinking? Well, I had used the test points. And the test points were fine, but like I could have used the negative 6. I could have used the negative 10. I could have used the negative 100. Could have used the positive 1,000. Those are not the actual numbers that are going to be working here. It was the 4 and the 2. And that's what I messed up on. So think of it like this. I typed this original into my math lab, and it goes, no, you're wrong. And I'm like, well, what am I wrong about? And I can go back through and see what I did wrong, or just submit it 3 times and see what their answer is. And they use the 4 and the 2, obviously, because those are the numbers that I had in the original. So I even get confused. Obviously, it's possible. Just watch out for that kind of stuff, okay? Just moving too fast, Chad. Just moving too fast. I know. You're probably playing this at 2 times speed still. this next question says find the percent of height. I think it's like of children or something like that. X years old. Okay, so X is years. And they give me a big old function here. 62 plus 35 log of X minus 4. And they say that we're looking at age 7. Like 7. And so guess what? X is equal to 7. Wow. And then you plug it in right there. Wow. And then you get a number. Wow. This is not hard. It's not hard at all. Okay, like, oh no, it's a word problem. Yeah, whatever. It's not a big deal. I want you to take it not very seriously because it's not a very serious problem. There's more decimals that I wrote down, but you just round it to whatever they need. Cool. And this is actually the last one in this section that I have for you. So here we go. There is another function. F of x is 5.4. Make that look a little bit better there. ln of x and then plus 18. Okay. And it says x is years after 2000. And it says, does this over or underestimate the graph? Now, there's a graph attached to this problem, and it has all these bars and stuff, da-da-da-da-da. And in 2019, which is the one they're asking for, I'll go ahead and say that here in a second, blah, 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 2019. So x is equal to 19. Anyways, at the top of the bar, we have a 34. Okay, so what I'm going to do is plug in the 19 and compare it. I feel like we've done this before, because we have. Okay, and I got 33.89997%. Okay, and again, you round to whatever they kind of say. I'm going to compare it with the 34, and wow, they're really close. So whenever you do round it to a whole number, and they do say to round it. So when you round it, you'll get 34, and you'll also get 34. 34 here, 34 there, they're the same. And so you say those are the same. They don't underestimate or overestimate. They're the same. So click same, because they're the same. All right, that's all I got. Thank you very much, and have a great day.